Hello everyone. In previous videos, we already completed lanthanides elements. Today videos we have to discuss actinides elements. Actinides are the epoch elements which includes 14 elements from thorium to lawrencium of the 7th period of the periodic table. So in case of actinides elements, it is also include 14 elements that is similar to lanthanides elements. Usually this series starts from thorium to lawrencium of the 7th period of the periodic table. Let us see this periodic table. Usually actinium series also places separately in the bottom of the periodic table because of the similarities in electronic configuration and the properties. Usually actinides elements starts from thorium and end with lawrencium. This series also includes 14 elements in the periodic table. The series starts with thorium, protosium, uranium, neptunium, plutonium, armenium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and then lawrencium. Totally 14 elements are there in the period of the periodic table. And then what is the electronic configuration of actinides elements? Usually the general electronic configuration of actinides elements, it is also acquired rare gas configuration. The atomic number of radon is 86. Radon gas configuration into n minus 2 into f to the power of 0 to 14 into n minus 1 into 0 to n minus 1 into d to the power of 0 to 1 into n minus 2. That means in f orbital can accommodate 0 to 14 electrons, whereas in case of d orbitals also accommodate 0 to 1 electrons. Okay, suppose if in case where n is equal to 7, I already told n is equal to 6 for lanthanides, n is equal to 7 for actinides, but it is difficult to predict the exact electronic configuration because there is a slight energy difference between 5f and 60 orbitals. So that's why the incoming electron either enter 5f orbital or 60 orbitals. So that's why it is difficult to predict the exact electronic configuration of actinides elements. And then have to move what is the oxidation state for actinides elements. Usually actinides elements also have variable oxidation state from +2 to +6, but first few elements are stable with higher oxidation state, whereas in case of heavier actinides are more stable with +3 oxidation state. In actinides elements, first few elements are stable with higher oxidation state. Keep in mind, heavier elements are most stable with +3 oxidation state. This is the oxidation state of actinides elements. And then we have to move atomic and ionic radii. In atomic and ionic radii, we observe a decreases with increase in atomic number. Only in a slight decrease is observed due to imperfect shielding of f electrons. But whereas in case of lanthanides elements, also we observe imperfect shielding. In case of actinide elements, we observe imperfect shielding. Whenever we are increasing the atomic number, we observe slight decrease is observed in the period of the periodic table because of the imperfect shielding of the f electrons. Okay, this is in case of lanthanides elements we observe lanthanide contraction, whereas in case of actinides elements we observe actinides contraction. So that similar to lanthanides elements. Okay, and the magnetic properties of actinides elements. Usually actinides, many of the actinides are paramagnetic in nature. That paramagnetic properties that depends on the number of unpaired electrons, spin, orbital motion, and also ligand field strength. So that similarly in case of lanthanides elements also depends on the number of unpaired electrons, spin and orbital motion. One extra property is there, that is ligand field strength. This is the magnetic property. But in case of actinides we observe transuranic elements. So that what are transuranic elements? Let us see this chart. In case of actinides elements, except first one thorium, fructosium, uranium, the first three elements are natural elements. The remaining elements are artificial elements or man-made elements. So that these elements are synthesized by using uranium, that we call transuranic elements. Keep in mind, in the periodic table first three elements are natural elements, the remaining elements are artificial elements. So that it is prepared by using uranium, so that's why it is called transuranic elements. Example of transuranic elements is the plutonium, hermetium. These are the examples of transuranic elements. Okay. And next we have to move what is the comparison between d and a block elements. So we already completed the d and a block elements.